Hi everyone, welcome back to this channel. I thought I'd give an update on my kind of programming language project thing. So there's not going to be any Zig in this because I haven't actually got to Zig yet. Basically what I decided to do was convert this into LLVM. And I'm doing this not the traditional way at all. Because generally what in LLVM you use is a thing called an AST, which is basically just a class. I'll show you a representation of what ASTs normally look like. Here's just an example generated by ChatGPT of how you do this. Basically, you create class AST node, and then you basically have everything extend from that using inheritance. You have a struct definition, you have a variable declaration, you have an assignment, function call, and then you have all the stuff inside that. I don't like doing this. I hate this so much. I didn't really want to. Also, I had a problem getting LLVM to even work, trying to get the dependencies to work. So I decided to do everything on my own from scratch. Literally everything. So here's just an example of if statements. If statements are pretty complicated in LLVM IR. So this is my language. Pretty simple. Just create 10. If it's 10, say the number equals 10. Literally all I want to do. So let's convert it. So we convert this into LLVM. Right, so that's the top, the inputted code. This converts to this. This is what the LLVM it converts into. So I'll copy this and I'll show you what the hell any of this means. I do actually understand what this means now because I've had to learn it. Here we go. So, so we declare printf, which is just using libc. So it's just going to call printf. That's how we print to the console. So allocer will allocate an i32 on the stack. We store the 10 value in that. Then we need to get a pointer to that, because if you want to use any variable in LLVM, you need to use a pointer. It's the only way you can do anything. So you create a pointer, and what I do is I have a variable that I increment every time I use a pointer, so I'm not having a duplicate variable. Because imagine I have number 0 and then another one, and then create another number 0. It's going to give you a duplicate variable. So I basically just add a underscore 0, underscore 1, underscore for every one I use. Anyway, so I get this value, and why? So here, so I get the value in number, and then I compare it. So we have I compare, meaning int compare. We're comparing integers equals. So this is basically just use this to make a comment. If number equals 10. That's basically all we're doing here. You int compare. The problem with ints in this, with if statements in LLVM IR, is if it's not an integer, you can't use I compare. So you have to it has to be a float compare, or if it's a string, you have to do like an array compare. Anyway, so it would depend entirely on what the thing is. So you got to track all this stuff. And then we have this condition thing. So this is br branch I1, which is a bool, which is a byte, is 1 byte. Condition 1. Condition 1 is this, what we just created. So this is a bool variable, and it's true depending on if this is equal or not. Basically, if it's true, go to the if true branch 2. If it's false, go to the if false branch 3. And if false branch 3, I basically always have an if branch, an else branch, just in case there is one. If there isn't one, I just go straight to end for. Basically, what it's like is like go to. It's kind of like works like go to in C. So basically, if there's a true, go to this block. If it's false, go to this block. That's all we're doing. And then we have this monstrosity. So what we're doing here is we're creating a string. That's all we're doing. We're creating a string. Of course, the only way to do it really with actual human way to actually do this is to make it a constant at the top. Because if you make it a constant at the top, I don't remember actually how you write it, but you can actually do it in human letters. But basically what I'm writing here is this. %d, it'd be like new line and then null terminator. I don't know how you write a null terminator. It's basically %d, new line, null terminator. That's all it is. So we have 37, which is percentage, d, which is 115, which is d, 10, which is the new line, and 0, which is the null terminator. That's basically what we're doing. So we're just creating the format which you're going to send to printf so we can print this out. And then we got the actual, I don't even know what this is. So yeah, this is the string, because we're printing out here we're printing out number equal 10. So I've got to create that string as well. So we create 18 char array, and then we got to also you got to use pointers to access anything in LLVM. You got to use pointers. So we create a pointer to the first element, 0 element, and then set it to this. If we create a pointer to the first element, this was index 1, and put it to that. You got to do that for everything. So literally 18 pointers I create. So I create 18 pointers and set each variable. Yeah, number equals 10 or whatever. So it'd be numb like this, and you have to set them. It's basically the same as doing this. So you create I don't know, char array 18 like this, and then you just go array 0 equals 110, array 1 equals 170. That's basically what we're doing, but it's just a really long convoluted mess. But you don't see this anyway. It's generated for me, so I don't see what I'm doing when this happens. So that's just creating that. Then we get a pointer to the first element. I could use this, but I don't know what the number is, because the number might not be 0, so I don't know. So I just get a pointer to the first element. Then we, I don't remember what we're doing here actually. Sorry, yeah, this is the format. So we get the format to the first element of the format. Also, they've got to be null terminated strings because we're using printf. So you have to put the null terminator at the end, the 0. Otherwise, you'll just go forever and, until there's a 0 in memory, which is not a good thing to do, because it basically uses C under the hood. So we get the format, a pointer to the format, and then we get a pointer to what we want to print out, and then we call printf. And then we branch to the end block, which returns 0, and if it's false, we branch to the end block, which returns 0. There we go, and I've done like the simplest code you could ever have in LLVM IR. So I'll show you all the if statement types. So these I haven't even done yet, but obviously the problem is with LLVM, you can't do really advanced stuff. Say for example in C you could do stuff like this. You could go if number less than 0 or number higher than 60. You could do this. You can't do this in LLVM. What you need to do is break this up into multiple blocks. So instead you'd have to do something. You'd have to convert this, which means I'll have to like basically rewrite everything. I'll have to basically convert this into this and then pass it, which is kind of annoying. So basically I have very simplified if statement branches. So here, int var is less than int literal, int var is greater than int literal, int var is equal to int literal, int var is equal to not equal to, so basically I've got to do all this, because it's a different operator every time. And I have to convert the operator into that. Because I need to know what it is, basically. So I have a generic function that will generate this for me. But I basically needed to know what this is, and I have at the top. So here we have signed less than. Signed, I don't know what LE means. Oh, sorry, signed less than equal to is SLE. Got these really kind of vague kind of abbreviations. Signed greater than, and if it's unsigned, you got to use a different one. So unsigned less than, unsigned greater than, unsigned less than or equal to. So I've got to track if it's signed or not. There's also no signed variables in LLVM. They basically just use, say for example, I should probably rename that to the correct form. I'm not using it anyway. But say for example, you create something like U32 get off number, make a comment so it doesn't complain at me, equals 10. That will basically be an I32 in LLVM. And you have to track yourself whether it's signed or not, and then use the correct comparison if it's signed or not. If that makes sense. This is complicated, right? And then basically I print all this depending on what it is, and then just put this signed greater than, signed equal to into that. So basically it will just put the comparison operator here. Of course, for strings, I haven't done strings yet, because strings are basically arrays of characters with null pointers, with null terminators at the end. So I'll need to basically create an array comparison and then compare it to another string literal. So it won't work with this at all. So we basically have to write everything separately. So if it's a bool variable, if it's a bool variable, it's completely different. If it's an int variable, if it's an int literal, it's completely different. If it's an int variable, also you've got to track the variable types. So I've got basically declarations where I track the string global variable names, var type, global variable types. I'm going to add more to this as well for, mutable variables or not, whatever, and track that later, but I can't be bothered at the moment. So local variable names, local variable types. So I have to track the type and then basically find if that exists. So this project is so complicated that I actually made a Trello project thing to track everything. And I've even filled out all of these stuff. But basically, yeah, I mean, it's going to take a long time. It's going to take months for me to finish this. I don't even know why I'm doing this. It's just an interesting project to learn with. Yeah, and plus, I'm only doing this in C# right now. And then I have to convert this into Zig later, just to give me a project to do in Zig, because I don't actually have any projects in Zig. But yeah, it's pretty complicated. I don't know why I'm doing this. Live mistakes were made. I'm regretting my life choices.